Just forgetting to do all the things. Look at that. I have a face that's not covered in hair anymore. It's like a Christmas Day miracle. I look different. Okay, so what we're going to do today is work on pathing for AI. We're going to have to skip restore because we can't restore. I largely don't care about importance, whatnots in this. So essentially what we want to do is we want to make it so instead of him going this way, he goes around. Shit. Because that's going to be important. Right? So we need to make areas that are less desirable for all intents and purposes. It's pathfinding. Let's actually watch a YouTube video. Yeah. That seems really interesting. Unreal Engine nav. Mm.
Nito Studios, back for another episode of the Designer's Week course. Today we're going to be talking about setting up a nav mesh. Getting a little laggy on the frame rate here. Using the game that I'm working on right now, Limerick, as an example. So we're going to set up a nav mesh right here on this balcony. And again, look, we're not going to be talking about like moving an AI around on the nav mesh or anything today. Just purely how do you set one up and how can you edit and tweak it a little bit if you need to. So the first thing you want to do is come over here to your Place Actors menu on the left side. If it's not there, go to Window, make sure the Place Actors pane is indeed displaying. So by default, it looked like this, and you can see I've already been searching in it. If you search NAV nav, it is going to come up with this right here, and you're going to come grab one of these nav mesh bounds volumes, and there you go. And it should be pretty intuitive from here, right? Let's add.
Navlink proxy. This is for linking. Override modifier allowing applied. I think the mesh bounds are probably what I'm looking for.
I just want some collision, well not collision, but pathfinding up here on this balcony. I'm going to drag this out really quick. Let me bring it over here. Let me drag this out just a bit more. Let's drag it out in this direction, and then we'll bring it this way a little bit. So, boom. What's easy to do is look and say, okay, well, have I succeeded? So if you'll hit the P key on your keyboard, it is the hotkey to show the nav mesh data. And you can see, hey, that looks great. Life is good. I am ready to get moving and grooving. And indeed, this would work really, really, really well. However, there are some tools that you need to know about. And what we'll do is I'm going to actually turn that off for a second. And let's start demonstrating some of the issues that could pop up. So I'm going to come down here to my content browser. I hit Control and Spacebar to bring that up. In my case, I have a chair in my project. If you didn't, then obviously this would not work. I'm going to bring that chair in. It's colossal. It's way too big. So we are going to come up here and scale this dude to 0.4. And now let's bring him up here. And now let's go ahead, and you can see even as I move things, it's camera box. It's in the way over here, but it's rebuilding the navigation. If I hit P, you can see it's working, right? It is determining, hey, I can't go to where that chair is. However, man, it is giving that chair a really wide berth, and that can be an issue. Because what can happen, I'm going to hit the G key to go into my game view. You can also hit P while you're in the game view to see the nav mesh as well. But if I was standing over next to this chair and I was able to get in that little dead area, especially if you're not a phenomenal programmer like me and you're using pretty simple blueprint functions to move your AIs around, what will happen is when you get into the dead zone, the AI will kind of be like, oh, well, and he'll give up, right? He might stand there and stare at you. Sometimes he runs off to, like, I don't know, make a sandwich or something and greet some friends. He just ain't got time for you anymore. And it can be annoying and it can be a problem. So this is a case where I probably want to refine this a little bit. Now, there are a few ways you could go about trying to do this. And what I've seen a lot of people talking about on the web is if you come up here to the world search, right, or the searching through the assets in your level and type in nav, you have the nav mesh bounds volume, and then you have this recast nav mesh actor here. That looks like recast nav mesh. You know, a little bit repetitive. And you can come down in here to the generation settings here, and you can kind of start to try to tweak these numbers. But I'm going to be honest with you. And I can demonstrate it by trying. In fact, I will really quick. Anytime I mess with these, it doesn't go the way I want to. For example, the cell size, you're probably like, oh, that's the size I like the cell, so I'll bring it down to 5 and it'll get really accurate. No, that's not what happens at all. All right, so I'm going to put it back to 19. And look, hey, there's probably somebody out there that knows way better than I do, but I just find that trying to tweak this thing doesn't work very well. So instead, let me show you some of the little tricks of the trade that I use. First of all, I would come here to this chair, and in any asset like this that you bring in that is generating, affecting the nav mesh, you can search for navigation right in here, and you can click off of can ever affect navigation, right? You can uncheck that. And you can see that immediately, now the chair doesn't affect navigation. But now we have a second issue, right? Now the AI doesn't think it's there at all. So if I was standing on the opposite side of this and it was standing opposite to me, it would just stand there and try to go through the chair and not be able to, and the AI would look incredibly, incredibly stupid, which we don't want that either. So how then would we fix this? What I would do is, again, back over here in my Place Actors pane, I search for nav, looking for all the nav mesh tools and stuff. And there's this nav mesh modifier volume. And you can see that as soon as I bring it in, what it does is it blocks off an area. You can, let's get rid of this search over here. Over here in the details panel, you can change this to be different things like null, low height, obstacle. I'm sure you can set up your own custom. We're not going to really worry about any of that. We're going to leave it to the default, which is that it blocks off areas of the nav mesh, right? To just kind of say, all right, look, you may not see an obstacle, but I'm telling you there's one here and you can't go here. So we're going to kind of bring this over towards where the chair is, right? And there we go. We're getting in pretty tight. We're not quite there yet. So let's go ahead and squeeze this in a little bit more. And now you can see, especially if I take my chair and kind of just line it up just so here. It's still a little bit wide this direction, so I'm going to go back and I'm going to squeeze this in just a wee bit more. And now I'm going to grab my chair. And there we go. That is pretty good, right? I'm going to go ahead and turn that off. Things are looking good. Go to our game view and actually turn this on, and you can see, man, I'm lined right up with the legs there, and there we are. Now, I know you might be thinking in your mind, well, Daniel, that means I have to sit there, right, and like manually try to do that. And this is what I would say. You're going to get what you want to do the work to get. A lot of times the nav mesh will work really, really well, and it's going to auto-generate. You're not going to have to worry about it a lot. But you're going to find that there's certain objects in your game that you use, especially like in what I'm working on, where I'm working on this kind of stealth environment.
This isn't quite what I'm looking for.
Hey guys, in this video we're going to take a look at the nav mesh recast object. So we'll start by going to Edit, Project Settings, and then we'll type in Generation. And these are the global default options that you can set for your entire project. But then on each individual map, when you pull in your first nav mesh, it'll automatically generate a local recast object, and you can use this to change the values specific for this map. And in this video, we're going to go through all of these values, so let's go ahead and get started. Okay, let's go ahead and get started by grabbing our recast object. Then we're going to come down to Display, and we're going to hit Draw Poly Edges, and that's so that we can see the tiles that were generated. Then we'll come down to the Generation section, and we'll expand the Advanced part, and we're going to start off by focusing on region partitioning. So what region partitioning is whenever you first place your nav mesh, it's going to be in this nice, neat grid format. But then as you start to place geometry, it's going to disrupt that grid, and it's going to have to reorganize itself into polys around that geometry. So now let's go check out how the different partitioning methods do this. And we'll start off with the default method of watershed. in this one you can see that the polys are evenly distributed around the geometry, and that's going to be helpful when you have more geometry near it. And then we'll move on to monotone. And in this one you can see that the distribution is not so even. This is because it's a low-cost calculation where it's just trying to take all of these vertices and snap them to the closest point on the side of the tile that it can. Now this will save on resources for your computer, but it'll come at the cost of accuracy whenever this geometry is near other geometry. So now let's go over and see what both of these look like. Okay, and here we have a pretty typical setup where there's a hallway for the character to walk through, and with watershed partitioning, we have some pretty even nav mesh throughout all the corners. But pay attention to this area right here. We're going to set it to monotone, and we can see that it got cut off because of that low-cost calculation. So even though there's just barely enough nav mesh for the character to still get through, this is going to become more and more of a problem as your map gets more and more complex. Okay, now let's go ahead and take a look at chunky monotone. So the best way to visualize this one is to think of it as like subdivision from something like Blender. So what that means is that we're going to take all these bigger tiles, and we're going to subdivide them down into smaller tiles, or chunks. So the default is 2, but I'm going to set it up a little higher so we can see. And now all of those bigger tiles have been subdivided down into smaller tiles. And these smaller tiles are monotone, so they have the low-cost calculation, and that's okay because now there's so many of them. So the strength of this method comes from there being so many tiles close together. So when would we want to use this? Well, here on a map made with the landscape tool, if you try to use one of the other methods, it might not work out as well. But if you use the chunky monotone method, then all of these extra small tiles may be more effective. Okay, let's just do a quick recap of the partitioning methods. We want to use watershed on maps that have a high concentration of geometry. We want to use monotone on maps that are wide open and have a low concentration of geometry. And we want to use chunky monotone on maps that we made in the landscape tool and have a lot of contouring on them. Okay, and let's take another look at this area. In the previous section, we decided we wanted to use watershed to give us a nice even amount of nav mesh to work with, and now we want to take that nav mesh and smooth it out into the corners. So to do that, we need to set our cell size and our tile size. So let's talk about what those are real quick. Your nav mesh is made out of cells. Those are the actual points that the characters navigate around on, and then all of your cells are organized into tiles, and these are the green lines that you're seeing on the screen. So what we want to do is we first want to choose a cell size, and then we want to choose how many cells per
So this is the size per tile squared. That makes sense. And the cell size is probably this.
tile side, and then from there we will have the total tile size. So with that cell size, and then we into tiles, and these are the green lines that you're seeing on the screen. So what we want to do is we first want to choose a cell size, and then we want to choose how many cells per tile side, and then from there we will have the total tile size. So what that looks like is, let's start off with the cell size. It's currently at 60, but we can see that that's making things a little too blocky, so let's cut it down to 30. And it kind of changed a little bit, but it didn't really have any improvement, so we'll cut it down again. And now with 15, we can see that there's a lot of improvement, but let's try and keep going. We'll go down to 10, and now there's even more improvement. It's really getting into the corners, and we'll go down to 5, and we'll stop there. That's the most improvement that we would need. It's really tight into the corners and around all of the geometry, but because the cell sizes are so small, that means it takes that many more of them to fill out the nav mesh. So as a result, you see it took a lot longer to generate the nav mesh, so that's considered to be a high cost. So what we need to do is we need to find a balance between how much accuracy we need in all of these corners and stuff, and we need to balance that with how expensive that nav mesh is. So we'll go back up to 10, and there's pretty good accuracy, and the cost didn't seem to be that bad, and we'll go back to 15, and there's more than enough accuracy than we need to get through this hallway, but you notice cost-wise, the nav mesh generated very quickly. So we'll stick with 15 for this example, and now that we've chosen our cell size, the next thing we need to choose is how many cells per tile side. So we're not choosing the total number of cells in a tile, because the tile is going to change shape and stuff. What we're doing is we're choosing how many cells are on any one side of the tile. So it's a very simple calculation. We'll just pull out a calculator, and we'll just go a cell size of 15.
Oh, so this is actually divided up.
And let's just choose a random number, for example, 30. So if we were to say 30 cells per each side of the tile, it would just be 15 times 30. And that would mean that the total size of the tile would be 450. So now the question is how do you choose this number? So according to the Unreal documentation, the nav mesh is optimized for anywhere between 32 and 128 cells per tile side. So we'll consider that to be our upper and lower range. So let's start off with the lower range of 32. So we'll go 15 times 32. So our total tile size would be 480. So let's go ahead and plug that in. And whenever you change your tile size, Unreal will give you a new suggested cell size. So if the suggestion is working for you, you can keep it, but we're going to go back to the one we wanted of 15. Okay, so now we have a tile size of 480 and a cell size of 15. So let's first check out the accuracy. With the cell size of 15, we kept all of the accuracy, so that's good. But now that the tile sizes are 480, they're a lot smaller, and so again, that means it takes more of them to fill out the nav mesh, and so if you notice, the nav mesh generated a little more slow. So we've accidentally increased the cost again. So we don't want to change the cell size because we like 15, but let's choose a new tile size. So we'll do that upper range. We'll go 15 times 128, and that'll give us a new tile size of 1920. So let's plug that in, and then we'll redo our cell size. And so this is pretty good. So now with the tile size of 1920, everything generated pretty fast, meaning it's low cost, and we get to keep our accuracy of 15 cell size here in the tight geometry. Okay, so in this example, I pulled in some spiral stairs, and these ones I rescaled so that they'd be a little more challenging. So we're going to try out that lower range of 32 and see if we can get similar results that we do over here. Okay, so the first thing I'm going to do, since this is a lot tighter geometry, is I'm just going to lower the cell size down to 10. And already we can start to see the nav mesh generating in, but it can't get past this certain point and make it all the way down. Now before we move on, let's go back to the display section, and we'll hit Draw Tile Bounds. And now we can see that the nav mesh is trying to draw more tiles up the z-axis of these stairs. So if we go down and revisit the partitioning method, we don't want to repartition the whole map, but if we do just the layering section, and if we remember that chunky monotone was really good at deforming itself to uneven terrain, we can try that real quick. And now all the extra layers have generated in, and the nav mesh makes it all the way down the stairs. So that's a good technique, but we're going to undo it because we want to focus more on the cell and tile size for this example. Okay, let's give this another try. So I know I want to keep my cell size as 10 because of how tight the geometry is, but we're going to need to choose a new tile size. But I don't want to go all the way to the bottom of the range at 32 because this is already going to be pretty expensive. So let's start at 40 and work our way down. So we'll pull out our calculator and we'll go 10 times 40, which will give us a tile size of 400. So let's plug that in and we'll reset our cell size. Okay, and at 40 it had no change. It still cuts off at the same spot. So now let's try 39, which would give us a tile size of 390, and we'll redo our cell size. And now there was some change, but it doesn't really help because it's not able to cover the entire stairs. So let's go down to 38, which would give us a tile size of 380, and we'll redo our cell size. And now we're able to get the nav mesh to go all the way down the stairs without having to go to the bottom of the range at 32. So this is the highest cell and tile size we could use for geometry this complex. Alright, we've been using some really small numbers for cell size and tile size, but that's because of the type of geometry we were facing. If you were doing a game that had a very wide open map, like an open world game, you'd probably have cell sizes of like 50 plus, and that would give you tile sizes of like 3 to 5,000, and that's okay for those types of maps. But other than that, I think that's everything we're going to need for cell size and tile size, so now let's move on to all the other options. Okay, let's go ahead and take a look at cell height. Now, what cell height is normally we've been thinking of the cells as X and Y.
This is cool and all, but also not really what I want. um,
Hello and welcome to this tutorial. In this tutorial we will use the integrated AI pathfinding system to find the best way to our destination and make it visible for us, like this. So let's go. The first thing that we need is the AI itself, so right click, blueprint class, character, and let's call this AI sphere. Open this up. This gets some sphere component just to make it visible. Let's go to the event graph. We can delete everything except for the begin plate, that it's moved the movement, and we will change the max acceleration to 900. Place it into the world here, open up the details of our AI here, and we can select our target point. The next thing that we need is the nav mesh bounce volume. Let's place it into the world. Go to the top view because we make this over the whole map here. So the volume has to be the same size of the map, and when you press P, you can see now it is over the whole map and clarify the navigation here. So when we now hit play, the AI moved to its target and it does it so fast that you can't even see it. The next step is to make it visible which part the AI actually took. For this we will use these three parts here. I already prepared one. So we have, for example, this straight street part here, just a static mesh, and also add up these box collision here. This is just the nav trigger. So when the AI moved to this street part, it recognized this one here. Also we have this plane component. When I go to the details and make this visible, you can see it's just some plan with a green texture. So let's make this invisible so we can change this later. As well, we have this nav block. This is also a box collision on each side of the road so that the AI can't move to the sidewalk, only on the streets. So let's select the nav trigger here, the box collision, go down here on begin overlap. So we just want to cast to our AI sphere here. We take out the plan here and want to set the visibility to true. And that's it, so we make it visible. For us here, we have the amount of costs it took to the destination. And when we now go to the level, every part, let's go to the project, the functionality inside here, as well for the T-cross here, like this one. To understand how the AI calculates its path, let's go to the project settings and type in cost. You have the draw polygon costs. And when we now go to the level, every part of the level has its own cost. So the AI will calculate the less amount of costs it took to the destination. So that the AI don't go straight to the destination, we have to make obstacles. For this, let's open up our road again. We have our nav block collisions here. We have our navigation tab where we can select the area class, and let's select the obstacle. And check the dynamic obstacle to true. Also, we will do this for the other parts of the streets, like this one, as well here, like this one. When we now go back to the level, you can see these red areas here, where it shows that the cost is much higher than the other parts, so the AI will avoid these parts here. So every time I move this target point, the AI will find his best way to get to the destination, like this. Of course, you can always optimize the AI by modifying the character movement. For example, the max step height you can put to 10, or the ground friction to 1000. Also, you should remove these three objects so that you don't get any collision problems. I hope you enjoyed the tutorial. If you have any questions, please let me know, and yeah, goodbye.
Hi guys, in this video we want to take a look at how to create a custom shaped nav path, so let's go ahead and get started. Okay, so what we want to do is draw a custom nav path where the player can walk along the dirt trail, and in order to do that, we're going to create a couple of brushes. So we'll get started by going to Select, then Brush Editing. We'll choose the pen tool, and I'll set my extrude depth to 100. This is how tall the brush will be. Then we need to be in an orthographic view, so I'll choose the top down. And
this isn't quite what I want either. Unreal Engine.
Hey guys, I'm Tesla and I'm back with another quick Unreal Engine 4 tutorial.
I think I forgot to paste that last one. I don't have it anymore.
this one, we're going to take a look at navigation mesh boundaries and updating them in real time. So what I mean by this is having an AI character simply moving from point A to point B, but then we'll put objects in front of him. The character will then know there's objects in front of him, and he will then find another way to point B. I would highly recommend trying out my basic AI navigation simulator. Now, you see
That's not what I wanted either. Real engine spline. I think this is actually it.
Welcome to this tutorial where we will be continuing to delve into artificial intelligence by looking at pathfinding cost. So let's jump into it and see how this works. So here we are inside of Unreal Engine 5, this is Early Access 2, and this will be very similar in Unreal Engine 4 as well. So essentially what we have already prepared here is that I've made a little level. It's a very simple level, just so we have something to navigate around with. We have an AI, which is being controlled and has a very basic behavior tree. The only thing it does is it goes after the player, and when it reaches the player, it waits for 4 seconds, and then it starts chasing it again. So that's essentially what this does, and to demonstrate it, this is what happens. So it just runs up to the character, stops, and then continues. And that is all that we need for our purposes today to learn about pathfinding costs. So whenever a AI decides that it wants to move between 2 different points, it takes into consideration its environment. So if we were to press P, you get to see our nav mesh. And for this to be useful, we want to see the nav mesh costs. In Unreal Engine, by default, this is turned off. In Unreal Engine 4, I believe this is turned on. Regardless, you can go to Edit and Project Settings, and then you go to, under the Engine category, you have Navigation Mesh. And here we have Draw Polygon Costs. So if we mark that one and we go back out, you can see that we have these areas which have a cost to default fixed and then some numbers next to it. So the number to the left is essentially a pathfinding cost, and you can see that all of these different areas all have the same cost. They're all showing as 1. So when an AI wants to move from one point to another, it takes into consideration these different costs in these different areas to make sure that it is going with the path of least resistance, sort of. It will take into consideration that if there is a strip of area that is lower cost to traverse, it will most likely use that as long as the traversal area is long enough for it to gain benefit from that, instead of going the straight direction to whatever object it's going for. Now, there are a bunch of different ways that this is determined. The navigation mesh that we have to begin with, as I said, has the cost of 1, which is default, but you can also bring in other volumes to affect this value. So if we go to create and we go to volumes, you can see that we have something that's called a nav modifier volume. We drag it out and you see that we have this little box here. Now this box by default has something that is called a nav area null class connected to it. So an area class will determine what kind of a cost is associated with the area that is covered by the volume. So to start off, you can see that this volume is covering this area of the ground, and this area has become gray. The reason for this is that this nav area null will act as an area where it's not allowed to move. So if we were to scale this, for example, you'll see that it will exclude more of the nav mesh that the volume is covering. So this has essentially become areas that are now off limits for this AI to walk through. So you can see that it's taking, by pressing apostrophe, you can see our different nav meshes. You can see that if we place ourselves somewhere, he will go around, avoiding this whole gray area in the middle, because that's not allowed area to walk on. And you do have a few other default nav area classes. You have a default, which is just going to be the same as everything else, so it's going to be a cost of 1. You have the null that we talked about earlier. We also have a low height, which is, you can see, has a really weird cost here, and this one is presumably used for determining areas that you can crouch into and such. You also have something that's called nav area obstacle, and if you walk in closer to the cost, you can see that it has a value of, I think it's 1 million or 10 million, something like that. A lot of numbers at least. And you can see a different colored area in here. So these are the default ones that we have available to us if we want to exclude areas within the nav mesh, make them more difficult to traverse and such things. To begin with, let's demonstrate this expensive one. If we were to rotate this, and this is an example that I'm replicating from the Unreal Engine documentation, just to prove how this works. So we currently have a wall over here which goes from this wall to this wall over here. The only opening is over here where we have placed this volume that now has this cost of 1 million, which is quite a lot more than 1. This is, however, just a determination, used for a determination of to see which path is the best path. If an AI, however, is only able to reach us if we're standing over here, and the AI is over here, this is the only path to reach us. It doesn't matter that it costs a lot, it's still the only way that it can actually reach us, so it will still walk through. So let's demonstrate that by walking past the AI when it has stopped and placing ourselves over here. And you can see it will walk over here handy dandy, no problem. To demonstrate that this does have an effect, though, what we can do is we can make an opening in our wall, something like this. You can see we now have an opening over here. So if we were to be over here, and the AI is over here, it will determine that this path is way too costly to reach us, and it will instead walk around here where the costs for the pathing is much lower. So let's demonstrate this quickly. You can see the character is running around. So that is how this works. You essentially can create areas where you want to discourage an AI to move through, or encourage an AI to move through, by having different costs associated with the area that the volume is covering. And the purpose to do such things would be something like, maybe you have a train track and you want to make it so that the AI appear to be cautious about their environment. They don't want to jump on a train track because they can get run over by trains. Or maybe you want the AI to more commonly walk certain paths when it's patrolling or something like that. Then you can put in areas where you put in lower costs, making sure that it will spend more time in those areas than other areas because it will try to find the path of least resistance, sort of. So these are all good and fine, but you have the option to make these yourself. To tweak the functionality a little bit, or the
This is what I
it's very easy.
wanted.
You just go to create a new blueprint class, and you open up this little all classes, and you type in nav area. You can see here we get all the classes that we have as default to begin with, but we can just choose nav area as our parent, and we can call this BP nav area expensive, for example. And then we open that up, and this is what we're greeted with. So it doesn't contain a lot, and essentially all that we have is, that's all importance is over here. We have a draw color, which will be the color that is going to be displayed on the floor for an area that is using this nav area. We have a default cost, which is going to be representing this cost that we see over here that's by default 1 and 10 million or 1 million over here in the expensive part. And we also have a fixed area of entry. And this is a cost that is taken into calculation, like, let's say you had something, an area that was very easy to traverse. It had a low cost. So let's say it was asphalt or something like that. But around that asphalt, you had a moat dug or something like that, some kind of trench or ditch, making it difficult to traverse up to the asphalt. What you could do is set a low default cost, making it very cheap for an AI to move once it is on that area, but have a steep entering cost to make sure that it takes into consideration that getting to the asphalt is not easy, and as such, this should be taken into consideration as well when it comes to calculating which is the best path to take. Anyway, so what we can do is, you can find some kind of way to color code your areas being easily distinguishable if they're expensive or not, so maybe red might be a good color for something that's expensive, and if we were to put something like 100 in here, how you use this is, we save this, and we take another one of these volumes like we had over here, and now that we've created this blueprint over here, we have available to us over here now a BP nav area expensive. So if we set that, you can see that we get the color that we had chosen, and we can also see our number here, 100.000.
I wonder if I can
Now this area
assign
over here is
these.
considered expensive, and if we
So I wonder if I can assign these to specific characters, though.
were to, you can see it's already trying to avoid this area as much as it can, because it's very expensive to it. So this is how you can tweak and make numbers more and less appealing to walk over or walk through. So this will be the representation of whatever the area that the volume is covering. In addition to making things expensive, you can also make things cheap. So if we duplicate this, we call this nav area cheap. So when we open that up, we can go and take a different value that's below 1. So if we were to take 0.1, for example, and then we change the color to maybe yellow, just so we have something to distinguish from the normal green I was thinking. And then you drag out, that's not what I wanted to drag. And this volume, copy that. We change the blueprint to the cheap one. You can see that this area is now affected by the cheap one, which means that if our AI finds itself sort of nearby this area, it will be quite inclined to see if we can position him. So if we place ourselves over here now, you can see that it will run towards the yellow area to traverse us rather than the direct straight line that he actually had available to him. So I hope that made sense. This is essentially how you can manipulate your AI movements in certain paths or keep them away from certain areas, and also make it so that it feels like the AI is taking into consideration the actual terrain it is walking through. The normal. In addition to making
Nav area. Unreal Engine nav area. Hit the previous. Filter class. Send the appropriate nav area to each type of AI agent in the navigation system settings. You can do this you'll find options to specify nav area, types of agents. First, you need to find a nav area. Types of AI agents. Nav areas are essential navigation modifications. Assign nav area. Assigns the appropriate project nav systems, and there you'll find options to specify the nav area corresponding to which type of agent. Force rebuild of logs. Draw input geometry past generator. Draw tile resolution. This is actually all just important. Tile bounds. Oh, look at that. Okay, so this is actually kind of important to know that this creates this. So even though, so this is wasted. This is wasted. This is going to be wasted. This section here is going to be wasted. Hmm. Hmm. It is nice to be able to visualize it though. Hmm. Draw label on path nodes. Path nodes? Nodes are nodes that represent key points along a navigation path that an AI character follows. These nodes are part of the navigation system and are used to define the path an AI agent should travel from one location to another. Huh. Huh. Unreal Engine path nodes.
Bum 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 bum.
Tomatoes?
Dude,
Hello, welcome to the video for what
you're one pencil stash away from looking like one of the worst historical figures in the world. Eat shit.
is AI behavior tree decorator, the does path exist node. So I fired up a quick little example. We're actually going to run through the example and then I'll cover how the node works. And
That's not the one I wanted. Review navigation path. Okay. How are you doing, by the way? True. This would be like this is just gonna be a test. Test. Thank you, D1. One sec. Let me go get this. One Dr. J Dog 1. Thank you for the follow. Much appreciated. Gets the modifier value, right? Yeah. So my goal is to have this increase, but have him still prefer walking through it. So this should be expensive, but he should still want to walk through it. And I need to have some way of distinguishing between these two. Okay, there we go. There's straight up nothing. Okay. In Unreal Engine nav areas can Unreal Engine JSON P powerful. Thank you for the follow, much appreciated. Unreal Engine nav area node only affect set actors. You look like a top game dev? Oh wow. If only. Thank you for the biddy. After a while being inactive today, I got a small idea, but is it possible to make a nav mesh, ignore certain meshes / actors, or simply to thank you again for the biddy, taking the #1 spot there. Stay there for a very long time. Or simply to work on a set of desirable actor classes. Even better if can ever affect navigation. You can set the bool can ever affect navigation in C++ or BP to make an instance of actors whose class of actors, by setting in defaults, be ignored by collision systems. To be honest, I was expecting you to reply, I knew you had an answer. Okay, so this is not the answer. Need a different nav mesh for a different AI. I read a bit of this one and it wasn't really what I was looking for. Okay, so there's our nav, but I think this is just gonna be like a box, right? Yeah, this. Ugh. So essentially, all we have to do, the only thing that we can do is be like 1,000 there, and now they're gonna try and walk around it, right? Oh, interesting. They walked through it. Wait a ding dong moment here. They were straight up just walking right through it. It's like, oh, hey, yeah. Maybe because it's not big enough. So essentially what I've got to do is just essentially do this to like create a situation where they'll walk in a very specific manner. Yeah, it's just going to be essentially this. right? There we go. It really doesn't. Apparently, that's just not high enough. No, that's low. Obstacle. Obstacle. Look. Then we come back over to here. This just becomes an obstacle. The reason why it matters is because I'd like them to Why is he coming after me? Thank you again for the bets. They straight up don't care about it at all. Wait, they straight up just do not care at all about the nav mesh. They're just like, oh, hey, you know, this is fine. Look at that. They're just crossing over the... It's so good. All right. Save all. It's this. This is like the thing as it is, right? Add a test. Pathfinding. Actually, what was pathfinding if we hover over it? Path cost. Oh. Regular navigation area applies to the entire navigation data. Nav filter AI controller default. Let's see if this fixes it. It totally broke it. Environment query test pathfinding. Unreal Engine EQS. The pathfinding test can be used to determine if a path exists to or from the context, however expensive the path to or from the context is, or how long the path is. How expensive is the path to or from the context? The pathfinding test can be used. The pathfinding test can be used to determine if a path exists to or from the context, how expensive the path to or from the context is, how long the path is. Every processed context paths will be scored depending on the defined test mode. This is let's do 5.3, see if they've got different documentation on this. The dot test calculates the dot product of two vectors. These can be context rotations or vector from one point to another to test if this test is useful to determine if something is facing something else. Interesting. Okay. This is a distance. The distance test will return the direct distance between the item and the chosen distance to property. Interesting. The gameplay tag test enables you to specify a gameplay tag to query to attempt to match to your test. Opens the gameplay tag editor when you can where you can specify tags to validate against. Can be used to determine if an item or items are within the bounds defined in the properties. Let's see if there's anything on this. I'll give you exactly 2 minutes to solve this issue. Oh, well, I failed. I got a prime set her hand. We'll send it your way. This is probably going to be actually making 5 minutes. It's going to be probably substantially longer than that. I've got to figure out some stuff that ChatGPT made. Like yes, maybe. Unfortunately, some of the issues with ChatGPT is that like it doesn't really know the answer for a lot of Unreal stuff. Like the more advanced you want to get into Unreal, the less ChatGPT understands, because it's not documented in such publicly in such a way that ChatGPT has the ability to get it. So kind of learning as you work with this platform seems good. I'm a software dev, so kind of learning as you work with this platform seems good. Yeah. Learning along with you. Oh yeah. I figured that's what you meant. It's surprising how. Oh, thank you for the for the Prime sub. I hope you enjoy your fireworks. Getting all the fireworks today. Because it doesn't seem to want to, like, EQS doesn't recognize these collision box, like these nav things, which is kind of annoying. These nav areas don't get recognized by EQS. Because it would make my life a little bit easier. Unreal Engine EQS not counting for nav areas. Not the most elegant or performance friendly, but you could have a version vision cone and add a nav modifier component. You could, not quite, since my player controller is using the nav mesh itself. The nav modifier value is not a scene component, so putting it on my actor did the job, but the null area didn't move the player with the player. I couldn't find anything like that, but I did find about nav filters. It's not particularly elegant. Let's see what some of these other ones are. There's our context. Score only. What if it's a filter and score? Test volume. We don't actually, I don't think we actually need this. If we uncheck this, I wonder if it just skips over it. Norse. No, that's not it. What if I change this to filter and score? Let's see what happens when I do this. Okay, so we're going to put this back to score only and see if they're able to move. Okay, they're able to move. They completely ignore the bounds, though. Fuck's sakes. Create a blueprint from the nav area. You can create a new blueprint class from the nav query from class. You can vehicle. Open the default properties of the blueprint and add 3 nav areas. Nav character only. 1 equals nav character only. For nav null, toggle checkbox is excluded to true. This will disable navigation from these zones. Clean cut pseudo. Yeah, I went and I got a haircut and a shave today. Using filters is very easy too. Movement blueprint node. Nodes like move to location, move to actor, AI controller class, have input drop down where you can select filter filter for navigation. Select your custom navigation query filter vehicle. Create in step 2. We don't have a date for it yet, but worked on. Meshes can overlap, and your characters will be able to move between them without any trouble. I don't seem to be able to get that to work. Every character just moves through the nav modifier that is set to character only. Also, generated nav meshes. Nav mesh is only color default green by nav mesh modifier. Doesn't change color of mesh, so I suspect that the modifier isn't generated a mesh for itself, and my characters are simply using standard ones. Any ideas? Wait, is there a nav mesh that I can directly attach to these guys? If set shapes will be exported for nav meshes dynamic identifiers. Sweep nav while walking. Project nav mesh while walking. Update nav agent. Preferred nav data. Oh. Oh, okay. Interesting. Okay, so it is working. It's just only working to a degree. What about this one? If I go here and I go to nav, that's the winner, but that shouldn't be the winner. You should not be trying to walk through this. You should be walking around it. What if I crank this up even higher? So let's crank this up really, really high. So what's that? 2, 3. So that's 1 million, right? Six zeros. 2, 3, 4, 5, 6. There we go. So now they're the same. What if I add one more 0? Will this affect his ability to walk through it? No, he still does not care. Great. I love it. I love it so much. I think EQS ends up being the issue here. I wanted to do EQS, and I'm going to have to not do EQS at this point. AI. This blows. I really wanted to just do EQS because EQS is actually really nice. It's just, it's not going to work for this, which sucks, but it is what it is. Okay. So what we could try where's character? Footman. Blueprints. We're going to do that. Then we need to get a location, find random patrol, essentially. We're going to duplicate that for all intents and purposes. Get random patrolling location. Get location. Get target actor location. I think that's how it ended up being here, right? Task setup, chase player. Wait, is this is 4. We're going to come up here. We're going to change this to 5-3. Chase player. Receive, execute AI. Yeah. Yeah. Don't actually care about doing that. Update speed and all that. Finish execution. Move to enemy actor. Okay. So if I come back into here and we just go to this, we can actually just... It's not being used anywhere. So we just come to here and we do target actor. Move to enemy actor. What was enemy actor? It's yeah, it's just oh wait, it's because enemy actor isn't actually set, isn't it? Wait, it's set to me now. Why is it set to me? Oops. Okay, so at least now it's working. Okay, so we know that it's working. Except for, you know, it's kind of not. So I think what we need to do is we need some way of setting the target actor. We're going to go to our context. Jetpack, machine gun. It's not the EQS stuff. Where is this being set again? Target actor is set. Result change low priority. Sure. Is not set. That's not really what I wanted. Oops. Actually, I think this is only being referenced in that one spot, right? Yeah. Here's our pawn. Get turn. I think this might not have worked, and that's why I wasn't using it. Finish execute. That's what it was. Move to target actor. Oh, look at that. It worked. And they're moving through correctly. Beautiful. Now I have a way of Oh, right, I'm not using that anymore. What the fuck? Oh, right, because it can see me. I forgot I had that. That's the, like, sight thing. It's... It's this. So good. Okay. Hmm. Wait, what is this? This is behavior tree. Oh, that's right. Poopy. We'd have to go in and like do a cast and everything like that. I guess because this is a pawn, we could probably cast to BP AG character base. From here, right, we could probably do a get behavior. Let me make sure that I spelled this right. Does not have. Okay, interesting. At any rate, I want to promote this to whatever, right? But we're going to actually make this a cast to AG enemy base. Promote variable. AI character. Then from here, we're going to get a get behavior, right? And because it's not available right now, we're going to actually add that in. So we're going to go to enemy base. We're going to jump over to here. We're going to do what was this? This was a behavior tree object reference. view behavior tree, get behavior tree, returns behavior tree. This should be a forward declare, and it might have, actually no, because we're gonna just do it here. That should be fine. Does this have a super on it? Can I do this? Super. No. Sweet. There we go. U function. Blueprint callable. Category. Here we go. Oops. Shave all. For some reason, and I don't know what it is, I find that the save all does not always work. I really need to change this. Will this allow me to jump to it? There's a trace error somewhere in, I think it was in here. Yeah, right here. I just don't care anymore. We're not using the C++ one. We're using a Blueprint one because the Blueprint one has more logic baked into it that we actually want. There we go. So this chases after the target, which I don't actually want it to chase the actual perceived actor. I want it to chase any actor that I don't want it to chase any actor at all, right? And I don't actually care about the actor tag. I want to make sure, I want to see if the actor has a team applied to it, right? Now, if I'm not mistaken, what I've done is I've added a team. Yeah, AI player team, right? So what we can do is we can just say, hey, does this actor get player team, right? If the player team is the same as my player team, which we're going to cache because we're going to use it a lot, player team. Right? If we've done this, we can come along here and we can do from here and do AI character, and then it would be get player team. Get player team. And then this will be, oops, wrong one. There. Now we don't have to grab it every time, right? Now what we're going to do is we're going to come down here. And we're going to check. There we go. So save, compile. These are both blue team people. Let's see if I can get a blue team. I'm red team, so I should be viewed, but I'm not being viewed because perception's not updating for some reason. And it's probably because we're not running this the way that I really, really want it to. This isn't being triggered enough. So we have to come back into this Blackboard. And the problem is that this is all bad at this point. So we're just saying move to the target actor, which isn't really what we want. We actually want it to move to a point, right? Want to move it to a point, but only if we don't have other things, right? So give me 1 sec, I'll be right back. So I got to figure out how I can get the task to run. Perception to run even if, it's like if I do this F9, right, we're not going to, it's either that it's not running or it's, so if I hit play, does it ever run? Okay, so it does run, right? Wait, are we on the same team? I didn't even check. Oh, we're on different teams. Totally on different teams. Wait. So I go to the blackboard. Okay, so acceptable radius. Okay, so it changes the target, but it still walks towards it no matter what. Which, to be honest, actually isn't exactly wrong, because that's kind of what Torque wants. So I guess we're good. Well, actually, wait, what did I just delete? Okay, so this is going to be the first thing. Get target locate, target actor. Then I want another actor for this to hold. But I think what we want is to probably change this in here so it attempts to shoot at the player as long as they're in sight and within a certain range, right? So I care about this, but I don't. Perceived actor. I clicked over to restream and it totally just like freaking lit up with fireworks because of how backlogged it was on video. Okay, so if I come into here, wait, where is it? Where's our blackboard? Here. And if we do this, go here, result on change, value change. For itself. Okay, let's see if this changes anything. There we go. Okay, that works. Okay, so that totally worked. Okay, so my hypothesis did work. So I don't actually want this. This is fine. Move to. This is fine. But we do want to interrupt this to some degree, maybe when we go through, because I think this doesn't like. Let's see how this works. Actually, wait. I know. What we're going to do is we're going to add a delay. A 5-second delay. Okay, so what happens is that the character is currently moving towards the target actor, which is the enemy base, the red base. And it will not trigger the next part until after it hits the enemy base. So we're going to have to add in a way for it to target something else. On that target, we're going to have to fire. So there's our target actor. What we want to do is have a new key of object, and we want this to be an enemy actor. Now, where's my blackboard? Here it is. Now what we can do is go like this, and we can add a decorator, and on change, abort self is set enemy actor. On value change. Then here we would do the attack. So this would be the BP attack situation, right? Either that or I don't even know if we really need this, to be honest. Give me a second here. Would they attack other enemies on site? I guess that's a great question. Let's see how they act with other enemies. Cool. Do these affect one another? Wait for it. Yes. There we go. Beautiful. We're about to not be in sight anymore. There we go. Beautiful. Absolutely amazing. Okay, so they do work the way that I want them to. Now, if we come down here, we need to add an ability to these guys, right? We're going to edit Footman Blueprint. And startup effects, startup abilities. We're going to add the machine gun. These guys are going to have little machine guns. There we go. Then what we need is we need the towers. What is our tower? Our turret is a AG tower base. So we're gonna close down a bunch of these. One, we want our stuff to be a little bit more organized here. So we need tower base. This is using should attack attacker. Should attack, wow, should attack attacker. No, should attack actor. Mm. Target's pawn. On attack range sphere, begin overlap. Try activate ability false. There we go. I wonder if I can just do this in here. Okay, let's go to the footman. Oh no, this needs to have like an entire timer thing set up to it, right? Footman, footman, footman. Enemy base. Add There we go. Beautiful. This should not be... Okay, wait. This will be a bool. If check team of enemy actor. Check if enemy actor is implements oops. Add to enemy actors array. There we go. So to start attacking, we can utilize the tower stuff, the tower logic here. This would be the start and the stop, right? Start attacking. We want a timer. I really hate what I named this thing already. So the machine gun causes a slight problem that because okay, so the machine gun causes a slight problem because the machine gun relies on the character to the player to hold a button. We're not holding a button. So it probably won't work. But that's fine because we can create a new machine gun based off the old machine gun and it will just work. Good times. Get target actor to do. What was I doing? Right here. I thought I just added it. Oh, right. There we go. This should never be able to be less than, but you should always just assume that it can. There's no reasonable reason why it should ever be. But making absolutes when you're dealing with a number that can fluctuate is just not a good idea. Because let's say that you're doing something and for some reason it comes back as sometimes when things are returned as numbers, a negative value will be something fucked up happened. In that situation, you don't want it to continue, you just want it to stop. So if it's negative, we'll also just stop. Although I think that this is always a positive number. Yeah, because I think size type ends up being a positive number all the time. I don't actually know. But whatever, it doesn't matter. Okay, what are we up to? On target time expired. This is what we want to find usage. Begin play. This was target time handle. Here we want tag time handle. And we want there. Now, let me take a look at this. Is this a const? No, it is not, because here we go. Actually, I don't think this needs to be a U function. It does, okay. Actually, I don't think it does, but we're going to do it anyways, just in case. Less than or equal to 0, return, which this should never happen. And the only reason why we're doing this is because we want to make sure that whatnot, we want to stop attacking. There. Okay, the reason why we want to do that is if we ever get into this situation, because we're about to get from the array, we want to make sure that we're not trying to get an array element that doesn't exist, because if we do that, we'll crash the entire application. It's just not worth it. Get the first mini actor. Okay. For some reason, I was thinking that there was a different way to do that. If target actor, if not target actor, return. This could happen because the target actor was destroyed as we were doing this, because things happen asynchronously. So it's always is valid. Don't care about that. Actually, we do care about this. Face to face the target. What we're going to do is we're just going to have this, so we don't have to query this. We're just going to say, hey, we're just going to have a Boolean. Has startup abilities. That's not the one that we wanted. Am I in the wrong one? Am I making this change in the wrong one? No. Yeah, no, I'm in the right one. Okay. If ability system component. On target, timer expired. Hmm. Hmm. I don't like this. Mm. I guess in this situation, this just might work. I don't know. It's a bit odd. Ugh. Mm. Mm. This actually works. We don't need a timer for this. This might actually be the way to do it. We cancel the ability. I don't know. I'm gonna take a little bit of a break. I will catch you all later. I'm overheating a little bit here. So I will see you in a bit. Thank you all for showing up, and ta-ta for now.